Hello students, my name is Dr. Kalalini Banerjee and today I am going to discuss on VLSI Design Automation 8th semester subject. VLSI is very important topic. The full form of VLSI is Very Large Scale Integration. Now, starting with the small scale integration, that is where the number of transistor was less than 10. Okay, when the number of transistor was less than 10, it is known as SSI, that is small scale integration. After that, it is MSI, where the number of transistor was 10 to 100, on the range of 10 to 100. And next is large scale integration, that is LSI, and the range of number of transistor is 100 to 10,000. And for this VLSI, very large scale integration, the range is 10,000 to around 1 lakh. Okay, so we can say that it is 10 to the power 4 to 10 to the power 6. Next is ULSI, that is ultra large scale integration, which is the range is 10 to the power 5 to 10 to the power 6. And this range is actually I am talking about the number of transistor which is there, or number of chip in that ULSI domain. And nowadays the number of transistor in a chip is quite large, that is almost in the order of 10 to the power 6. So whenever it is greater than 10 to the power 6, we call it as GSI, that is giant scale integration. But in this topic we will study VLSI, where the first topic I should start with VLSI design flow. Basically, VLSI design flow is a sequence of steps followed to translate the idea of a system into the chip. Okay, so system SOC, the full form of SOC is system on chip. So whenever we are taking the system into a chip, the sequence of steps followed to translate that idea is known as VLSI design flow. That's very basic point, that's very important, and for your semester purpose as well, this is one very important 5 marks question. So starting with the system specifications. Okay, the first point we can see here, it is system specification which includes functionality, performance, physical dimensions, and design techniques. So in that first step, it is one black box. So we don't know anything about that black box. Only the functionality, physical dimensions, the specifications, we are dealing with that in this first step. Next is functional or architectural design, where again that physical dimension, that means in this step the main functional blocks of the systems are identified. Okay, the main functional blocks of the systems are identified. The interconnect requirements are also identified in this second step. But the details of the implementation of each blocks are not considered here. Okay, the details are not considered in this stage. The third stage, okay, the third stage is actually it is next we have functional verification. So whenever any steps are there, into the next step we have the verification stage, where we have to check whether the designs are satisfied or not. If the designs are verified well and it is well satisfied, then we will go to into the next step. Otherwise we have to recheck the previous step. So it is kind of a flow chart. If it is yes, then go to the next step, and if it is no, then just recheck the previous step. So the third stage is logic design and logic verification. So in this stage, the control flow word like register allocation, arithmetic and logic units that represents the functional design are identified and designed. The logic level design is actually the gate level design. Okay, this is also known as gate level design. And in the verification part, any HDL level simulation is there for logic verification. And again, if it is yes, then we can proceed further to the circuit design, and if it is no, then we need to go back and recheck. The next stage is circuit design. So basically, circuit verification or circuit design is switch level design. Okay, and the another name for circuit is netlist. So this netlist design is in the switch level, and the circuit verification is mainly done by spice. Okay, the p spice, you know. After the circuit verification, we have physical design. Physical design is basically the circuit representation. That means in this stage, the circuit representation is converted into a geometrical representation. That means the mask design. The geometric representation of a circuit is called a layout. Okay, and we have that CAD software for layout verification as well. So this is the VLSI design flow, and in the next slide, one simplified VLSI design flow has been shown here. Again, this portion is known as behavioral representation. This one is logic or gate level representation. This is circuit representation, and the fourth part that I have already discussed, this is layout representation. So this is all about the first topic, that is VLSI design flow. And thank you.